Welcome to Mathematics Online Lecture Series by Professor K.V. Narasimhan. Today's topic, applications of multiple integrals. Already we discussed one application, finding the areas using double integrals. Today we will discuss about how to find the volumes using double integrals and also triple integrals. So first we will discuss about volumes. Applications of multiple integrals. So now application is volume. Volume using double integrals. This is today's first topic. We will find the volume of the solid using double integrals. So how to find the volume? So this is only for if the solid is suppose for example, now this is x-axis, y-axis, z-axis, and Y is the origin. If the solid is bounded by or above the xy plane, so z equals to f of xy. Then we will find the volumes using double integrals. Then how to find the double integral? If the solid, if the volume of the solid bounded by or above xy plane, then we will find the volume using double integrals. Then how to find? Suppose if you observe one example, first example. Suppose if you take a cuboid, a cube, then how to find the volume? If you observe the total cube based on xy plane only, so above xy plane, total above xy plane, then what is the procedure? Very simple for finding the volume. So divide into smaller pieces. Smaller pieces. So each piece look like again a cube. If you now this is the one of the cube. In the similar way we will get infinite number of cubes. If you add all the volumes of small cubes, then you will get the total volume. Okay. What is the volume? Very simple. Above triple integral dx dy dz. Dx dy dz is the volume. Z lies between this one to this one, Y lies between back side to this one, X lies between here 0 to this one. So this YZ plane to this one. So suppose if Z equals to f of xy, then nothing but our solid based on xy plane, above the xy plane, then how to find? Now what about the Z limits? Z limits 0 to this only, 0 to this function, suppose if it is f of xy. Suppose if you integrate with respect to z, now remaining two variables are x comma y, then we will discuss later. If you find the integral value with respect to z, integral dz is z, nothing but z. If you substitute the limit 0 to f of xy, dx dy. So now this is double integral is nothing but the projection of the cube on xy plane. This is R. So if we substitute that equals to f of xy, then integrate with respect to x. Now the simplified formula using double integral, if the solid lies are bounded above the xy plane, now after simplifying this thing, volume equals to double integral of z dx dy over the region where R is the surface in xy plane. This surface is a projection on xy plane, nothing but shadow on xy plane. So this is the procedure for finding the volume of the solid using double integral. If z equals to f of xy and z equals to 0 above the xy plane, then we will apply this formula. Now we will discuss about the problems using this concept. Now problems finding the volumes using double integrals. Now first question, using double integration, find the volume of the tetrahedron bounded by the coordinate planes and the plane x by a plus y by b plus z by c equals to 1. So using double integration, we will find the volume of this tetrahedron. What is the tetrahedron? Tetrahedron is bounded by the coordinate planes and the plane x by a plus y by b plus z by c equals to 1. So for finding the volumes, what is the procedure? First find out the region. Then second find out the limits. Then third evaluation of integrals. Okay. So if you observe, our tetrahedron is bounded by coordinate planes. What are the coordinate planes? Coordinate planes are xy plane, yz plane and zx plane. In three-dimensional geometry, xy plane, yz plane and zx planes are called coordinate planes. And also, so 4 planes and also plane x by a plus y by b plus z by c equals to 1. It is a plane whose intercepts are a, b, c on coordinate axis. Now this is look like this one. Our plane intersects 3 axes, x-axis at a 0, 0, y-axis at 0, b, 0 and z-axis at 0, 0. Now the shape is, back side is a triangle, this side is a triangle, bottom is a triangle and slant position is also a triangle. The shape is nothing but tetrahedron. Now observe, this tetrahedron is located above the xy plane. So our tetrahedron is, the base of the tetrahedron in xy plane. So if our surface is bounded above the xy plane, bounded and above the xy plane. Now what is the procedure? Volume equals using double integral, already we discussed the formula, double integral of z dx dy over the region R. What is the region R? The region in xy plane, nothing but the shadow of the total tetrahedron in xy plane, that is nothing but this one. This is a triangle. This is a triangle. If you find the limits of this triangle, then you will get the limits of this integral. So what is z value? From this one, x by a plus y by b plus z by c equals to 1. What is z value? 1 minus x by a minus y by b into c. From this one, z equals to, first replace the z value, then we will find the limits. Double integral of z is nothing but c into 1 minus x by a minus y by b dx dy. What about the limits of x and y? So, along x-axis means this one. So, along x-axis, lower curve is this one, then upper curve is this line. From this one, after finding the limits, leave it this one. From this one, what is the y value? From this one, y equals to b into 1 minus x by a. So, lower limit is 0 to b into 1 minus x by a. Along this one, suppose if you want to know, simply write like this, x, y. So, the equation of this triangle is, x by a plus y by b equals to 1. So, along y-axis, so lower curve is y equals to 0, upper curve is y equals to b into 1 minus x by a. Okay. After finding the y limits, now observe x. Now here x-intercept is a0, 0, and also along x-axis, if you observe, x coordinate is 0 here, 0 to a. So, what is the procedure here? First identify the region and also identify the region in xy plane, nothing but projection of for the solid on xy plane. Then find out the second part is find out the limits in xy plane. So, okay, xy plane limits, then integrate with respect to y, then integrate with respect to x. If you integrate with respect to y, other variables are treated as constant. C into x is 0 to a. Now it is very simple. 1 minus x is constant. 1 minus x by a into y. Y integration is y square by 2. Limits 0 to b into 1 minus x by a dx. Now substitute the limits. C into x is 0 to a. 1 minus x by a into b into 1 minus x by a minus b by b 1 minus x by a, so whole square into dx. Now here b and b cancel. Okay, here b is the common term. 1 minus x by a whole square. Now I will repeat again. 1 minus x by a is constant if you integrate with respect to y, integral y. Integral y equals to y square by 2 into b. Now substitute the limit, the lower limit is 0, upper limit is b into 1 minus x by a. Put y equals to b into 1 minus x by a. 1 minus x by a into b into 1 minus x by a minus y 1 by 2b. Y square is nothing but b square into 1 minus x by a whole square, b square cancel. Here b, now b and c integral x is 0 to a. Here 1 minus x by a, 1 minus x by a. Here also 1 minus x by a whole square. That value is common term. Here constant term 1 minus 1 by 2 into dx. Now integrating with respect to x. So 1 minus x by a whole square integration is 1 minus x by a whole cube. Now this is 1 by 2 is also there. By 3 into. So here constant term is minus 1 by a. Limit 0 to a. Now 1 by 6 now goes to numerator a b c by 6 into. Put x equals to a. 1 minus a by a is 0 with negative sign. Minus or minus plus. If you put x equals to 0, 1. So answer is a b c by 6. So this is a well-known formula. Volume of the tetrahedron whose vertices are 0, 0, 0, a 0, 0, 0, b 0, 0, 0, c is a b c by 6. Now we proved the volume of the tetrahedron. Volume of the tetrahedron is a b c by 6.